I'm your host, Sean MacKenzie. Thank you for joining me once again on my channel on data engineering. In this episode, we go back to our artificial intelligence playlist and our natural language processing sub-playlist of that, where we're using BERT, and we're going to take a look at how to move our current progress with BERT to do more training so that we can get a better result in our model. Now, in our last few episodes, we went through the process of, preparing our data and downloading it. That was the first episode. And then in the next episode, we did all of our programming for our model, and we got our model to do one epoch of training. And we got kind of okay results with that on our movie reviews. And now in this episode, what we're going to do is we're going to expand our epochs, and we're going to do 5 epoch, and we're going to train those so that we can get a better result. And we're going to see what that looks like. In our next episode, we're actually going to upgrade our model of BERT, and we're going to move from TinyBERT to small BERT, which is a much more powerful training model, and that will also be exciting. But for today, we are expanding our epoch, and we're going to get a better result than our first one. Let's get to it. Interested in more cool topics like these? Make sure to check out my Patreon. The link is in the description. Okay guys, so we have come a long way in our sentiment analysis for movie reviews. Here is the script we did last time. This is our folder that has our script in it that we can run, that we use to run our Python script. And then here is the download we got. Here is the unpacked download of all of the positive and negative reviews. So you can look at the data itself if you want to. You can see here, I've got this positive review here, and so we're evaluating whole paragraphs of text, and you can also test your own paragraphs at the end of this, and you can see how accurate your script is. And here are some negative review examples, so you can sort of get an idea of what those look like. And we are training our TinyBERT model on all of this data here. You can see there's 12,500 items in each of the directories, and we are training that. And of course, we split that data, the training data, into the training, and we had a validation data set as well. So there was a split there, and then we have the test data itself is split completely out. But in our last episode, we ran a single epoch. And so if I search for epochs here, you can see this is where we set the number of epochs, which is a complete training pass over the entire data set. So we only did one complete pass last time, and we'll change that this time. We're going to change the number of epochs to 5. So instead of a single pass over the data like it did last time, this time it's going to do 5 full passes over the data doing its training, and hopefully get better each time. And so I can run our script just like I did last time using the command line, and I can fire that up, and you can see it is now retrieving sentiment data, which actually it checks for the cache there, so it doesn't download it again. That's why you don't see the download happening like in our previous episodes. But in general, you can see that our script is firing up just like it did in the last few episodes when we started it, and it is just grabbing that sentiment data, and there we go. It's going through the cleanup, and that is what we want to see there. So we should see a bunch of action here. There we go. It has detected my GPU, and it is going through. It's found our 5,000 files for validation, which it's taking from that 25,000 from the training set, and the test data set has 25,000 in it. And we are doing our model and pre-process selection just like we did in our script there, and we're off to the races. So there is our epoch. So you can see that when it does this, it will run through the epochs sequentially. And so this is our first epoch here, and you can see it looks like it's running about 50% with the binary accuracy there, and our loss is also changing as time goes on here. We're right at the very beginning. It has split our epoch into 625 steps. and it's just sort of blasting through those using the graphics card. And you can see in the top right there that the CUDA has been activated. So CUDA is being used on the video card and using all of that sort of massive parallel processing that we get from graphics cards. And if some of you are running this on your CPU, you may notice that it runs quite a bit slower on a CPU than it will run if you have your NVIDIA GPU on your machine. So definitely make sure to go back to the episode I did where I talked about CUDA. It's a very straightforward process to get CUDA installed on your machine so that it will use your graphics card for processing. I think most of you are probably gamers and you have NVIDIA cards on your machines already, and those will probably be much better than the one that I have here on this particular machine. But overall, once you change your selection for the view in your task manager, you should see when you select that CUDA in one of your performance visualizations there, you should see that it is active and running. And if you have not changed your model, or if you chose a different model, you'll notice before we talked about choosing different models, there was one for Electra, I think, and there was some bigger BERT ones. Those ones will run much more slowly than this TinyBERT one. Okay, so we just finished one epoch there. You can see that there's some action on the CUDA there. It's going to drop a little bit. My GPU is heating up because I'm working it pretty hard for this old GPU that I'm using. But you can see now it goes through, it's finished one epoch, and it's doing the additional calculations to see, well, how good did we do? And actually we did not bad. That first epoch looks like it got a validation accuracy of about 75%, which is pretty good. Considering that we're using the smallest, so the least powerful, or one of the least powerful BERT pre-trained models that you can download. And you can see it'll flip over once it finishes, calculating that accuracy. It'll move on to the next epoch of training, and that's what it has done here. And so now you can see it's sort of blasting through the second epoch, and it's using that CUDA core again, which is what we wanted to see there. Now you might be wondering, well, how does it know how accurate it is if we've just been running over the training data set and we have not used our test data set yet? But if you go back to our previous video, when we were building our script, we actually did some steps where we cut out a validation data set from the training data. In fact, we used 20% of that data in order to do validation so that we could tell as we go on this journey through our epoch, we can tell sort of how well we're doing. And you can also take a look at your models and you can see if you're overfitting and things like that. And I will also note that in some models in deep learning, you might do 50 or 100 or even 200 epoch. But in other kinds of models, you might only do a few. And BERT is generally in the latter of those use cases. And so BERT, usually you can train, because BERT is pre-trained already, you might only use a few epoch to train BERT. In this case, I'm using TinyBERT, which is not so powerful. But if you use the larger BERT models, you might find that your training epoch number will be very low, and in fact you may even discover that you get declining accuracy as your model progresses. So make sure that you pay attention to that. We look like we're getting more accurate as time goes on here. So we started with 75% roughly, and we've moved to about 77%, and you can see it has moved on to the next epoch number 3, and it is sort of blasting through that one now. And so you can see the binary accuracy appears to be getting better as well. So we can watch that as the model progresses here, and it goes through the steps of the training. And so we're over 80% now, which is really great for the binary accuracy. We'll see how well the actual validation is when this epoch is completed. and so we'll be able to see what our training looks like. And of course, we will be doing lots of trial and error when we do these kinds of models, and you'll be able to see those and how they affect your training as you try different solutions. And so some people might want to change your optimizer. We are going to try to use Atom W in a future episode. That might make a little bit better performance on our model here, or get us better performance. You can also try things like changing your learning rate, because you might find in some cases that your model will train more smoothly and accurately if you have a smaller or larger learning rate. And there are lots of other things that you can try as well, which we'll look at in future episodes. Now we are finishing our third epoch here. You can see now we've got about 82% accuracy for our binary accuracy, and right now what it's doing is it's doing the validation accuracy, and that has come back as 78%. And that's pretty good. I think that's getting better as we go, so that's what we want to see there. And definitely we are seeing some better results, and it does not appear that we are in the territory of overfitting yet. I don't think we'll get there with just 5 epoch, but it does happen. But we are getting consistently better, and it looks like our validation's getting better at the same time, although it appears to be sort of declining in efficiency here. It's only getting a little bit better each time, going from 75 to 77.3 to 77.9. So I would expect this next epoch here, I would expect it to maybe be like 70, just over 78 maybe. Maybe just a few points better than the previous one. That even though it is a TinyBERT model, it is quite powerful still, and it is pre-trained, so I'm not sure how much better accuracy we are going to get with this model without doing other tweaks like I talked about, maybe changing the optimizer or doing some of those things, or increasing the size of the model, so going from TinyBERT to small-BERT, which those training epoch take quite a bit longer, and when you go to a full BERT model size, those ones will take quite a long time, even on some more powerful graphics cards. But let's see what we get here. Looks like we're at the end of our fourth epoch here, and our binary accuracy is still going up. It's at 84.3 there percent, and it's just calculating the validation accuracy to see how well we did, and it looks like we got 79.7. Oh, it actually did pretty well there. So as you can see, it's hard to tell how a model will train and how fast it will learn on each epoch. It really depends on a lot of things that are happening under the hood. But it looks like our model is chugging away pretty nicely here. We're on the last epoch, and you can see now our binary accuracy is pushing up into 85%, and that is pretty good. And so we'll see what we get for our validation binary accuracy at the end of this step. I am interested to see if we will get better results than 80%, which would be really great for using the very small the TinyBERT model, sort of one of the least powerful pre-trained models that we can get from BERT. Now remember, those were all in the big list that we put in, the big dictionary that had in our code in the script, that had a mapping, and it had the names of all the different models that you can try. And definitely the TinyBERT one that we chose is one of the least powerful, but it's also one that you can run with more limited hardware. But when we move up to small BERT, you'll definitely notice that the training time is much slower, and even if you have a more powerful card, it doesn't matter. It will be faster than my card, but definitely you'll notice a slowdown as you grow in model power and size. for your NLP, but the results will be much better too. So you'll notice that it will actually interpret the language much better. Okay, let's check it out. We are at the end of epoch number 5. It looks like we got about 87% almost in binary accuracy. So we're checking our validation, and we got 79.04, which is short of the 80% I was looking for. It was actually a little bit less than the previous epoch. So we were not doing quite as well on our validation accuracy, but now let's test it against the test data and see how well we're doing when we actually use it against some data that is completely separated and used only for test. And so let's check that out. So it looks like as we go through the test data here, looks like we are doing pretty well. We're about 78% accurate, and that's really great. We'll see if we get any higher by the end here. This is sort of like the final test to see how well we do, and then once we have our model, of course, we can use it. If it's a good model, then we can operationalize it. That's the whole idea. And in our case, we just created a little prompt that we can type in our own movie review and then get back sort of like, you know, a positive or negative result from our sentiment analysis here. So it looks like we're about 78%, and it seems to be pretty steady there as we sort of test against our test data. It does not look at this point like we will get over 80% as I had hoped in our 5 training epoch. Perhaps if we trained longer we might, but you never really know. Sometimes the training of one epoch actually goes down compared to previous epoch, and then it goes back up with spectacular results after. So sometimes it's very hard to tell exactly what's going to happen. So and so many analysts lose sleep over wondering if they have overfitted their models and things like that. Okay, so there we go. So we got a binary accuracy of 78 on our test data set. That's not bad. It's not awesome, but here is our loss graph. So we have a steady declining loss on our training, and the validation loss was not quite as good. So that could indicate something in the validation set that we took, that 20%. You can do things like randomize it and things like that to try to get better results. But here's our accuracy, and you can see our training accuracy was actually pretty good, but the validation accuracy was not quite as good. But we did end up over 85% with the training accuracy, validation accuracy. The binary accuracy stayed about 76% or 78%, somewhere in there. And so that's actually pretty exciting. So now we've got our model, our trained model in memory, so we can test it out. You'll note that we put this prompt here, and so the script is still running. That means we still have it in memory, but you can save it to disk and then reload it. We'll show how to do that in a future episode. But we could plunk in a review here. We could say, what a great movie. I think so-and-so was a fantastic villain in this movie, or something along those lines, and we could just see how will our newer model handle our new requests here that we are putting in by hand. And so we can type in a full paragraph if we want, or we can do a very short one, and it should give us it should have pretty good accuracy for that. So rest of the cast is well chosen and things like that, and that gets a positive review. You can see here that we've got our positive review, and it's 0.98 for the return, which is greater than 0.5. We could try putting in some language that isn't really language. We could try to say, I thought this movie was kind of meh, not really sure what to think, and see what we get there. And that says it's a positive review, and I would call that not positive. So that was kind of a false positive there. It gave it 0.81 on our tensor. So that's something to pay attention to, because we'll test that scenario again when we move up to the small BERT implementation, when we use meh there and things like that, and we'll see if the small BERT or the regular BERT implementation can do it, and get those meanings. Let's see, what a terrible movie. I can't believe I wasted $50. That's negative, and you can see that's a very strong negative review. That's pretty cool. That's what we want to see there. Let's try to trip it up again and put in something that is sort of not totally true or false. We could do something like I'm not sure. That seemed to trip it up last time, so I don't know what to think about this movie. And we could try something like that, and that gives a positive review. And so you can see that it can be sort of like tripped up and it's almost a negative. It's a 0.57 on the return. So we could say that's a lukewarm review if you wanted to do a multi-classification, instead of this binary one, because that would be kind of like, it's not a really good review at 0.57. It's kind of lukewarm, just on the side of positive. But this movie is great when it's better than the original. Solid work from director Sam McDuff. Let's check that out and see if that gets us a positive. So there we go. Yeah, that's a 9.97. Very positive review. So we can definitely see that our classification is working. Our binary classification, we are definitely up there. That was 5 epoch, and I think the 78% is probably accurate, but I do think that we can make this model much better, and we can also probably train it using the bigger model and or using other options in order to get a better result. But overall, it looks pretty good. This movie was good and bad. How about that? Well, some of the acting was brilliant, but the plot was terrible. Let's see what we get with that. I don't know what to make of this movie. Let's put that in there and see what we get for a movie review here. So there we go. And that is negative. That's what we want to see there. So as you guessed, you could play around with this all day long and try out all kinds of different language in your movie reviews and try to get positive or negative reviews. I think that was a very negative one. That was like a 0.01. It was very, very obviously bad. And so I would encourage you to go ahead and try this out. Do all kinds of movie reviews. Try different different sentence structures and idioms and things like that, and just see how well it does. And that's really good testing for the model that you have created. In our next video, we are going to move our model from the TinyBERT up to the small BERT implementation, which is quite a bit more powerful. And we're going to choose that from our list, and we're going to try it out, and we are going to see how well our training does with small BERT instead. If you guys want this code, make sure to check out my downloads page. You can find it on there. Need automated time collection for your staff and contractors out in the field? Make sure to check out my Bill Zone solution. The link is in the description.